All right, so this talk, for any of you guys that were lucky enough to go to Kafka Summit a few weeks back, will have already seen the shortened version of this. Don't worry, there's a lot more in this one. Just bear with me for the first 10 minutes, then we'll get past what we did in Summit and we'll get on to even more exciting stuff. So I'm going to talk to you about a process that we call safeguarding. It's really tools and techniques to protect your Kafka cluster from misbehaving clients, whether intentionally misbehaving or unintentionally misbehaving clients. So let's start with who I am. I'm a principal engineer with Conduktor. You've heard a lot about Conduktor tonight. I'm going to give you a lot more. Thanks for the setup, John. I might just use your slide deck instead of mine. It might be a bit easier. But I'm principal engineer on Conduktor Gateway. That probably doesn't mean a lot to you right now. Hopefully in about half an hour's time it will. I'm also 6 years plus in Kafka. Previously, I actually worked on the replicator product at Confluence and a little bit about that one. And 15 years plus in all things data. So let's start. This is going to be a bit of a story. We're going to go through an early Kafka journey, some of the pitfalls that you might go through, identifying some stages that you may be at, how to progress to the next stage, and anything that we can do to help. So let's start with why. Why would you want to protect your cluster from misbehaving clients? And the obvious one is this. Let's see if I can make the laser work. Hey. The obvious one is this first one, to minimize outages, right? Outages cost money and time. They're bad. That's great. But I think more importantly is the second point in here. A good solution to dealing with bad actors in your Kafka infrastructure allows you to respond gracefully to change. And that's a lovely little tagline to throw out, but what does that actually mean? Well, John's talked about business units in Sainsbury's. Everybody has their organizational structures and their different tenants that will be interacting with their Kafka infrastructure. These guys have different priorities, often contradicting priorities, and most importantly, they move at different speeds. A good safeguarding policy will allow these different domains, and I'm going to start calling them domains, use full-on data mesh terminologies, to move at those different speeds and reduce the friction that is the side effects of those movements. If you have a set of inter-domain contracts, it means that the side effects from a drastic change in one unit may not have quite as drastic an effect in the other. And this leads on to the next couple. If you have that kind of process in place and that friction reduced, you can align technical goals. Let's say we want to move everybody to be using schema registry by next year. That's great. If we have strong policies and strong enforced policies, we can chart our progress towards that and make sure that we get there. And the result, right down at the bottom, is velocity. And that's what we're trying to achieve. We're trying to make the most of our Kafka infrastructure. We're trying to demonstrate its value to the business, and we're trying to move fast. So let's put a nice sentence behind that. Safeguarding is the practice of protecting your data and infrastructure from intentional and unintentional threats, both internal and external. It's a lot of words, but don't read the words. Look at the picture. Safeguarding is the intersection of data governance and technical best practice in order to make sure that your Kafka cluster is safe, secure, and high performant. So I'm actually not going to go to that. Oh, it doesn't go back. Right, I am going to go to that slide. So at Conduktor, we've spoken to a bunch of customers about this very subject. And we've identified 3 real stages that customers tend to be at within their Kafka safeguarding journey. And the first one is stage 1. We call it safeguarding by habit. It's loose collection of rules and processes that are enforced by humans. And this is, well, actually, I would say you're far beyond this stage now, but you did a really great introduction. This is where people are normally at when they're first starting in their Kafka journey. What happens is there's this big rush where we get everybody to use Kafka and see the benefits. And it's a bit like the Wild West, things come out and then somebody goes, wait, we need to clamp all this down. I'm going to write a wiki page or a Google Doc or something like that that says, you must now follow these rules and it's enforced by humans. The example I use is the production readiness check. Anybody dealt with these? Anybody got production? Yeah, good. I saw some nods there. And they suffer from 3. These are like checks that you put in just before you go into production. It's a tick box exercise to say, I've thought about this, I've thought about this, I've thought about this. And they really suffer from 3 main problems. The first is relevance. Right? the person that writes these docs tends not to be a domain expert. Sometimes he is, and that's great, but they tend to be a lot broader than they need to be. Anybody who's ticked the box to say, I've guarded cross-site scripting attack from my Kafka applications know what I mean. They also suffer from timeliness. They're applied right at the end. So you've done all your testing, you've soaked it, you're ready, you're just about to go into production, and they go, yeah, now you've got to tick this box. And that really leads on to a perception problem. If you're just ticking the box the day before you're trying to go live, you're not looking seriously at anything that you could correct in order to make your application more efficient and better use of Kafka. You're looking to go, right, I met that criteria, let's tick the box, let's go. All right. So it's got a bunch of problems. And my next slide was going to be, this doesn't work. But I realized that this does work. And I've worked in organizations where this does work. But there are some really difficult caveats to make it work. First off, your governance, best practices, and data quality really must be at the core of your organization, which is a goal that everybody aims for, few actually achieve. Your communication must be absolutely excellent. The people that are creating the policies and enforcing these rules must be domain experts. And the most important one, stuck at the bottom, none of the above can change. And it does change. So even if you get this right the first time, that doesn't protect you from the second time, the third time, or the fourth time. So how do we solve a problem? Well, this is a manual problem. And how do you solve manual problems? You automate them. The second stage, we like to call reactive automation. This is where you've gone, okay, it's a bit like the Wild West here. What we'll do is we'll get all our monitoring in place. We'll get all our alerting in place. We'll put thresholds and checks in, and we'll make sure that if anything goes wrong in our Kafka infrastructure, the right people are alerted and the right actions can be taken. Sounds great. And this is where the majority of the people we talk to are now. It's very essential. I'm not saying, I know this is only stage 2, but go do it. It's important. But it leads to some interest, because of its reactive nature, it leads to some interesting problems. So I'll give you an example. Let's say you've just introduced a new application into production. Right? Your client latencies have gone through the roof, and every single tenant on that Kafka cluster is being affected. Right? The great news is you've got reactive automation in place. A threshold has been breached. Someone's PagerDuty's gone off. Everybody's on the call, and that's great. But now what? Now you have some uncomfortable decisions to make. Logic would say you just take that new application and you take it out. Stop it. Return this cluster to the previous state. But what if there are downstream dependencies on that application? And you're breaking everything for the other systems? Or what if that single application that you've just deployed is responsible for more business value than all the rest combined? It's not an easy thing to make, and you're making this decision during a production outage, and when time pressures and organizational pressures are really heightened. And that tends to lead to temporary solutions. We all know temporary solutions aren't temporary. They get taken out about 4 years later. And a bunch of tech debt. And what does tech debt lead to? It leads to a decrease in velocity. Entirely the opposite of what we were trying to achieve back on the first slide. So while reactive automation is a really important part of your protecting your Kafka infrastructure, it's not the be all and end all, and it's not the place we would suggest to stop. So I know I said there was 3 stages. We're about to get to the gold standard. So what we call the gold standard of safeguarding is proactive automation. It's the same checks and balances that you put based on your monitoring data, but we move where it's enforced. Instead of reacting to something that's already happened on your cluster, we move and we enforce these checks and balances at the earliest possible point they can be. And with Kafka, that's on the clients. So schema validation here is an excellent example. You guys all use schema registry? I always look for anyone shaking their head so I can go, no, you should be. Everybody should be using schema registry. But but if you are using schema registry, I'm sure you've all experienced the poison pill message. Right? There's a topic that uses schemas, and somehow, some way, a producer gets on there and produces a message without a schema ID in it, or with an incorrect schema ID in it. Let's do it. Starter for 10. What happens next? On the buzzer? Go on, John. I'm not sure you're allowed to play, but go on. What happens next? Best case scenario goes to the DLQ. Worst case scenario, all of your consumers stop. So all of your downstream applications stop, and you have to do some put in some manual intervention in order to decide what to do next. Do you skip the message? Do you? I mean, even routing to a DLQ may not be the right thing to do. So the reactive, I've just described the reactive scenario here, right? All our consumers have stopped, we've been alerted, and we must make an uncomfortable decision about how to unpick this problem. A proactive version of it would have detected that there was a poison message out on the produce side. Before it even made it to the Kafka cluster, it would have gone, there's the same threshold check, say, look, there's a message with no schema on it, and it would have rejected it immediately. So the difference between the two approaches is that if it's rejected, the scope of that issue is limited to the producing application. It's not made it into Kafka. It's definitely not made it downstream, and the blast radius of your issue is greatly reduced. There's another couple of small bonuses to this. Like if you're enforcing it as close to the client as you can do it in every environment. Monitoring costs money in every single environment. Enforcing clients, if you do proactive automation, you can apply in your dev, you apply it in your QA, you apply it in your SOAK, you apply it everywhere so that by the time the application gets to production, you are very, very confident that what it's producing is safe. And also, because there's also an issue of scope, right? If we take the schema validation problem again, if you think about it in the reactive approach, what I've seen is all my downstream consumers have stopped. That's the issue I've seen. Right? I've then got to unpick this and figure out what caused that to happen. In the proactive approach, I've seen this message was rejected because it has an invalid schema ID on it. And I've seen it on the producing application. So you get much more specific and detailed information on breaches. I know John touched on schema validation isn't the only one. There are a couple more examples. There are tons for these, and they can be customized to your specific organization needs. But John touched on partition count limits. That's also a good one to have. Don't let somebody come in and create a topic with 10,000 partitions. Or more subtle ones that we'll go into a bit later, like auto encryption and things like that. So we're at stage 3 now, and we're at Conduktor. We've sat there and we've gone, right, this is important. People need this. And we start thinking, right, how can we provide this service? Or how can anyone provide this service? And it became less of a how and more of a where. So it can be done in one of 3 ways, really. You can do it as a client plugin, as close to your clients as possible. We don't actually like this solution very much because you're going to need at least one client plugin for every single application you're running, which is a huge estate to manage. And any bugs or version increases in the plugin, you really don't know what you're getting from there. So we kind of discounted that one early on. A broker plugin has similar issues, but with less moving parts, I guess, less brokers rather than less clients. But you're still tied to a specific implementation. How do you get that plugin into the broker in such a way that it doesn't, and maintain it in such a way that it doesn't affect broker operations? And the one we really liked about here is a proxy. So the proxy would sit between broker and client, and it would act like a transparent barrier for misbehaving clients there. So why doesn't everybody have a proxy? We went looking for these, and there really aren't many of them around. And the answer is it's hard. In this gap between here, I'm going to use the laser instead. What you have is the Kafka wire protocol. The Kafka wire protocol is very low level and somewhat complex and somewhat arcane in some of the way it does stuff. And really not dealing with the Kafka wire protocol isn't really providing value for your organization, right? It's a huge step to take to achieve something that might not necessarily be quite worth that effort. So what you really need is someone to come along, do all the wire protocol bit, and abstract it away so you get some high-level things in which you can apply your own safeguarding rules. We call it Conduktor Gateway. There you go. Now you all know what Conduktor Gateway is. So Conduktor gateway, there are other proxies, by the way. I happen to work for Conduktor, and I'm going to use this to explain the concepts, but please go look at other ones if it makes you feel better. But Conduktor gateway, as you can see, sits between your Kafka cluster and your applications, and it provides this concept that we have. We call them interceptors. Interceptors intercept Kafka requests and responses, and they perform any amount of transformation, filtering, projection in order to achieve whatever goal you have. For safeguarding, these are usually filters. These are usually ways to reject poison messages, but they don't have to be. Gateway can embed one or more of these interceptors and order them to create kind of like a bit of like a data pipeline, but within your gateway and between your application and your Kafka cluster. And this is the most important piece at the bottom here. So from a client perspective, it doesn't see some specialist piece of software, say a Conduktor gateway. No, we're speaking Kafka wire protocol here. So all it sees is a Kafka broker and a normal Kafka broker that it interacts with in the same way as it would any other Kafka broker. So that means in order to take advantage of some of the features of Conduktor gateway, you just repoint your Bootstrap servers. That's it. And then suddenly your traffic's routed through the gateway into the backend Kafka. Now, this is the end of the Kafka Summit talk, but I got plenty more time with you guys. So I'm going to give you a bit more of the cool stuff we do. So I know I said there were 3 stages. Let's talk about a bonus stage. So you're lucky. You guys get the bonus version. So we've talked primarily about filtering and rejection of messages here, right? But I said before, that's not the only action you can take. We have our bonus stage that I'm showing you now is called transparent safeguarding. So it's a protection that the client doesn't see and the client doesn't react to because it just happens in the background. John, we talked about encryption a little bit earlier. Encryption is a prime case for this, right? You don't want your clients to have to worry about encryption because then you have to deliver them all the keys and you have to manage it across the entire client real estate. Instead, you want your client to connect to gateway. And before we say it, this link is TLS, so we're fine here. So you want your client to connect into gateway, produce as it normally would, and you get gateway to transparently do the encryption. So by the time that message hits Kafka, it's encrypted. And it's encrypted at rest, and you've met all your PII requirements, and everybody's happy. Same thing works on the other way around. You got your consumer come in, try and fetch. It doesn't fetch from the Kafka cluster. It fetches from gateway. Gateway transparently decrypts it so that the consumer sees the decrypted message. This is the whole core of transparent safeguarding. What it's doing is providing extra value and meeting your largely technical goals, but without requiring any input from application teams or from the clients themselves. Another common one is the check claim pattern that we use to deal with large messages, right? You produce like a 30 meg message from your producer. The gateway intercepts it, and instead of sending the 30 meg message into Kafka, it sends the data into your S3 or your block storage or somewhere like that, and it sends a reference into Kafka. And then the same thing happens on the consume path. It reads the reference, fetches the data, rebuilds it so that the consumer just sees the message as it would normally have been. So pretty cool, right? It gets better. Trust me. By the time we got to this point, we were pretty excited. But then we had a bit of a realization. We were no longer building pipelines and filtering anymore. We were enabling completely different architectures. Once you start using this proxying technology, you can start thinking about some really interesting patterns. I'm only going to go into a couple of these. So if we take this one down in the bottom left corner here, what we have here is rings of protection. We've daisy chained gateways on there so that maybe you'd have some loose protections around really nice and close to your Kafka cluster. And then maybe your app team would like to put in a further ring of protection closer to the application. And because they're all speaking wire protocol, they're all speaking Kafka, there's no reason not to do that. And slightly more, why not go the other way? Slightly more, one that needs a bit more thinking about. Why are you limited to one Kafka cluster? A gateway will allow you to slice and dice your Kafka resources as required and then represent them to your Kafka cluster. So you can have two Kafka clusters, but by the time they get through gateway, they're represented as one Kafka cluster to the application. This is really nice for streams cases. Anyone who's ever replicated data purely so that they can run a streams application on it will understand that it might be nicer just to have the two Kafka clusters represented and the streams application run on gateway. And this led us on to the core feature of Conduktor Gateway outside of safeguarding, which is native multi-tenancy. This, by the way, is also a safeguarding technique. It's also a transparent safeguarding technique, because what you are doing is you're assembling sections of a base Kafka cluster into a tenant, a completely isolated tenant that then goes to an application. As John was saying earlier, most people need a really, really strong naming convention in order to avoid conflicts between tenants on their Kafka cluster. Don't do that. Put Conduktor Gateway in, you don't have to worry about a naming convention at all. Right? Conduktor Gateway takes care of all of the isolation, and your applications can use it. For instance, a topic named orders in this application, and a topic named orders in this application could be completely separate and non-conflicting.
How would it know which orders to get then?
It's a great question, really great question. So today, we use Kafka's inbuilt SASL mechanisms. So your tenancy information is encoded into a token that you send along when you connect into the gateway. So, and it's not anything different. We use literally the SASL plain mechanism that comes with Apache Kafka. It's nothing fancy. We just generate tokens so that you can determine your tenancy information. Today they are signed JWTs. Yes, yes, it definitely is, because that's what we do today. Yeah. So today it's a signed JWT that does the authentication here, and that's how we determine the tenancy information. A couple more. How am I doing for time? I think I'm okay. Wait. Couple more. Really, this is where we get to a really exciting one. Hugh, I now know your name, Hugh. This is what we were talking about. For your testing scenario, this is what we call a test sandbox. So we put gateway in here. It reads input topics to your test application from the production cluster or from a pre-prod cluster or something pretty close, but they're read-only. We enforce that via a safeguarding filter, and they're read-only into gateway. And your output topics go out to a different, say, test cluster. Right? You would run your test application for as long as it needs to under there, and it's running on realistic input data. In fact, genuinely real input data from the same source as it would in production. It outputs its topics to a separate place where you can perform your reconciliation, and then you tear the whole lot down. It's just a curl command to set this up and tear it down. Tear it down, set up a new one. Tear it down, set up a new one. Run them all, because we have multi-tenancy, run them concurrently. Right? So it's a really nice use case for this way of slicing and dicing Kafka resources however you need to into ready for your application. Another one that this is to come. Okay, we're not fully fleshed this out yet. We got some demo working. Please try it, but it's not production ready yet. Another one is seamless failover. I'm sure a lot of you guys have been thinking about Kafka DR, and the biggest problem that we have today with all Kafka DR solutions is that in order to fail over, you first have to stop all your applications, all your clients, switch them across to the new one, and bring them back up, which is a nightmare. But because we've decoupled the serving layers from the metadata layers, there's nothing stopping you with, say, a gateway approach from keeping those applications running the whole time and just switching where they point to. So you can fail over, fail back, fail over, and the applications don't stop at all. The same one that you do with all replicated scenarios. Yeah. Yep. Yeah. So, but I agree, but coordination doesn't necessarily mean the application has to stop. It does have to be coordinated, but you can keep your applications running while you're doing that. We will debate it at length. That was a very, very whistle-stop tour. So let's give a bit of a summary. I talked about really two topics: safeguarding and the decoupling of storage and client serving that enables. So proactive safeguarding, it kind of feels like a minor aside now, but proactive safeguarding will help you prevent outages. Right? Moving those checks and balances closer to the client does protect your Kafka cluster in a way that will mean that you will experience less outages. But it also resets the perception around data quality and data governance and increases your velocity at the same time. I'd be remiss if I didn't tell you some of the things that it doesn't do, right? It won't define your governance and best practice policies for you. It definitely won't. And this second one is really important. It doesn't replace the reactive. I've had a few questions on this one that say, well, we don't need our monitoring once we've got a full suite of proactive solutions. You still do. There's a big class of problems where you still need to be alerted. You still need all the monitoring data in order to look at it. What it will do is greatly reduce your reliance on these kind of practices. And then finally, once you've implemented something like this, what you've really done is decoupled your data serving layer from your client serving layer. And this enables a lot more things. Things like isolation, multi-tenancy natively. Things like resource sharing, merging two clusters into one. And a bunch of new architectures that can achieve your business goals. So how can you get it? Conduktor Gateway today is available in two versions. There is an enterprise version that comes with full fat with all of the really awesome features that we spoke about. And there's a much lighter open source edition. So if you want to run the open source edition, go to GitHub/Conduktor/Conduktor Gateway. This will now allow you to start your journey with proactive safeguarding. We provide a framework for you to be able to develop your own safeguarding filters, and we provide some example filters for you to be able to run. If you're interested in the more enterprisey features, these Conduktor proxy demos here are running on the enterprise version, and they will show you things like multi-tenancy. They'll show you things like not talking about that one, haven't done it, haven't spoken, but some other features, more enterprisey features. But as always, check out the doc site. It's really useful. That's not happening. Normally, I would show you a demo here, but my laptop isn't hooked up to this machine. But that's it. Thank you very much. Any questions? It's entirely up to you. Gateway is a separate process, and there is no reliance in terms of location with the Kafka cluster. It's by itself distributed and resilient, so you would run multiple gateway instances. And all the communication is done via Kafka protocol. So we have some people that run it as a sidecar. We have some people that run it as a. We have some people that run it in a completely separate cluster. You know, it's up to you. Today, it's primarily distributed as a Docker image, and then you can slice it how you need. It's on the gateway today. We have had some requests for what we call transitive identity, which would be a pass-through to the Kafka cluster. But today, it's enforced on the gateway. So primarily, the config for the gateway is in a YAML that happens on startup. But anything that is dynamic, the gateway instances themselves are stateless, but anything that we need is persisted to the backing Kafka in a topic, in several internal topics via Kcache. Yeah. Mm. Yeah. Yep. So I'm going to completely cop out. It's entirely dependent on what you want it to do. So if you set up a gateway and it does absolutely nothing except pass Kafka traffic through it, the latency impact is like negligible. It's basically nothing. I think we saw something like 3 milliseconds at P99. Stuart can keep me honest, but yeah, it's the latency impact is negligible. Obviously, if you want to do some kind of complex filter, or even worse, anything that needs I/O, you've got to pay the cost of doing that. But it's equivalent. You've got to think of these things as end to end. Let's say we're offloading to S3, right? So we're doing it in the gateway. We're paying a high latency cost there. But if you weren't doing that, you'd be doing it in Connect async. So your latency end to end till the data in S3 is a different question. Gateway is Java today. I'm sorry.
So there are quite a few parts of the Kafka WAR protocol that ensure safety from a distributed systems perspective. So, for example, transactional APIs. There are things that if you put a gateway in there, just at a fundamental level, I can't get parity. Can you speak a little bit about that?
Sure. So there's less of them than you think. But so primarily, it is a pass-through, right? So we are modifying requests and responses as they go through and it's normally safe, right? There are, like you say, there are plenty of, particularly in transactional talking, and we've gone to pains to do that. There are some trade-offs. I won't talk in detail about them, but for proactive safeguarding, you don't have any problems with that kind. For more complex architectures, you will. Merge clusters, we had to do some special work to make that work.
With a single cluster, I can think of a case when I'm using the transactional APIs and I use the zombie fencing that Kafka uses for using a transactional ID. If you are doing if you're like re-implementing that and doing any logic on top of that, you now fundamentally cannot guarantee the transactional ID zombie fencing that Kafka does.
We can, because we can insert fencing, but I'm more than happy to talk about. You're right, there is a caveat here in that we need to pass the connection, the fence connection back down to the client. But we do that and it has slightly wider side effects. So what we've done in that case, is the fencing actually has a wider surface area than you'd expect it to, and the clients react. But we can talk in detail about it. So this is one where I probably need the code in front of me to talk about as well. So, any more? Yeah, there's a Prometheus exporter built in, and it provides a bunch of metrics, the usual stuff that you'd expect to see. So there is no ideal number. And what I want to talk about in terms of partitions is it's not always a technical concern, right? I find whether you choose 3 partitions for your topic count or whether you choose 6 partitions, it's okay. But in reality, your problem is that you've got too many topics, right? That's where it's really going to bleed. And these topics are created for organizational reasons, business reasons, for logical reasons, not for technical reasons. And so there's not really a lot you can do to get away from that. We have some technology in Gateway that allows you to compress topics down. So you can represent multiple logical topics with a single physical topic. And that's one thing we've looked at. But with this partitions argument, I always say, look at the logical case first. Look at if you really need a new topic for that case, and then save your partitions that way rather than squeezing it on the technical side. I'm not sure if that answers your question. The answer was no, there is no good answer. No, the most partitions I've seen in the last 5 years was about, for a single topic, about 3,500. And legit, perfectly good reason for doing it. One that I won't go into, but there was a good reason for doing it. Imagine if you have your entire Kafka cluster to serve one topic. Sorry? Have I seen? Sorry, I didn't hear you. Yeah, generally I'd say between the normal sort of partition count that people create from a basic application would be sort of between 6 and 50.
Clear understanding of how partitions, because if you take a data, you know how partitions, how it takes it, and based on that, we need the C right. We have a clear understanding of how partitions internally from the how shares code is defined or blocks. If we have an understanding, then we can have that.
Yeah, so it's the smallest unit of parallelism you have in Kafka, right? That's what a partition is, right? It's a construct of a number of segment files on disk, and it's resilient across the cluster. So that smallest unit of parallelism is what's causing the problem, right? So let's say we have a topic that stores my birthday message, right? My birthday was it's got one message a year, right? It's still using a partition. And these are the kind of things that I'd encourage people to challenge rather than going, do we really care whether that high throughput topic has 1,000 partitions or 100 partitions? That could probably materially affect my business, and I don't want to squeeze it technically just to get under a cloud limit or something. Where I should be looking is for the low throughput topics that are just there to provide a logical separation between applications.